tayo dito ang bagong module. Ano na naman yan? Ito. Ito yung tinatawag na TP4056 with protect. Meron dito mga pin out, tsaka battery pin out, input, output. And then dito protection IC DW01. Meron ding MOSFET 802 8205. Ayan yung switching MOSFET. Protection IC para sa overcharging at sa over discharging, para hindi ma-over discharge at ma-overcharge. At merong charging IC. Yan na nga yung TP4056. Ay, ano na naman ang gagawin mo dyan? Gagawa tayo ng adjustable current charging na power bank using this module. This is now our schematic diagram of TP4056 module. Schematic diagram. This is the actual module, and then this is the schematic diagram. What we have here is the charging IC TC4056 instead of TP4056, but it functions the same. This is IC is responsible for charging and discharging, and we have this IC, which is the MOSFET FS8205A. Two MOSFET is connected together, and then we have this protection IC for charging and discharging, DW01A. And we have the 5-volt supply, or it is connected to the voltage input over here, voltage in plus minus, or the mini USB. And for the output, out plus, out minus, it is for the load. For example, for the LED or a motor or LED, that is the load, output voltage. And B plus, B minus is the pin out for the battery. What kind of battery we are going to use? We're going to use this 18650 battery, lithium ion, with a nominal voltage rating of 3.7 volts, current rating of 3350 milliampere hour. So it has a current rating and voltage rating. So this one is to be connected to the B plus and to the B minus during the charging and discharging, connected here and here. Now let us see how this IC or this module functions. So when we're going to talk about charging, so we're going to charge the battery here, and since we have the protection IC, The overcharging is controlled by this pin number 3. In order not to over charging the battery, this IC is used together with the MOSFET. Once during the charging process, when we connect the battery here, and we're going to connect the input with the 5 volts mini USB, the battery is going to charge and protect. And because we have this protection IC, pin number 3 is the overcharging pin protection. Once it reaches around 4.2 volts, the charging will stop. Okay, 4.2 volts. We are charging at 5 volts, and the battery, if you measure the battery, it will stop at 4.2 volts because of the pin of the MOSFET is disconnected to the negative part of the battery, because this pin number 3 is a pin responsible for overcharging. It will disconnect. The current will not flow into the base of the MOSFET, so the current will not flow into the negative terminal of the battery, and the circuit is disconnected. The battery is disconnected once it reaches 4.2 volts for the charging. So the full charge is 4.2 volts full charge. What if the battery we're going to use now and we're going to connect a load, for example an LED to the load LED. We are now going to use the battery as a supply. So as I've said, we're going to use the battery as a supply, and we're not going to charge. So if the battery is used as a supply, it will going to supply through the load. It will supply the load. Going to supply the load, and there is also a connection between the B plus and minus of the battery. This pin number 1, it will disconnect once it reaches 3 volts. So the battery will now turn off. So for the LowBat, the LowBat is 3 volts. Battery LowBat 3 volts, disconnecting this gate of the MOSFET, pin number 1, because we are discharging the battery. We use the battery as the supply to the load. It will disconnect the gate of the MOSFET, and the battery will no longer working. So LowBat is 3.0 volts, and the full charge is 4.2 volts. Because of this IC, it will control the full charge 4.2 volts and will stop the charging, and 3.0 volts LowBat. So it means when the battery reaches 3.0 volt as a LowBat, it will stop from working. Okay? Remember, the output is the load. And then we also concerned with the charging current. If we have this charging voltage of 4.2 volts, 4.2 volts is charging voltage and a full charge. Now we are interested in what is the charging current, and it is controlled by this pin number 2 of this TP4056 module. Pin number 2 is the current sense resistor, 1.2K. If we are going to use 1.2K, it is capable of charging 1 amps of current to the battery. So if we use this resistor value, we are charging the battery with 1000 milliampere or 1 ampere of current to the battery, which is not good for the battery. So we need to change the value of this pin number 2 pin of this module located around here. Here, this one. Okay, so that we are going to vary or adjust the charging current depends on the capacity of the battery. If we need 300 milliampere for the charging, that is the ideal charging current for the battery should be around 300 milliampere for this type of battery, or it could be 400 milliampere hour. If we're going to use 1 ampere for charging this battery, it is not good for the battery. We are dealing with the fast charging process. So fast charging is not good. So we need at least 300 milliampere for charging as a charging current. In order to achieve that 300 milliampere hour as a charging current, so it will charge at 300 milliampere hour to the battery, we need to change the value of the resistor. That's why we're going to use another component. Ito na ang ating project. So meron tayo ditong 18650 battery. Ang supply natin adjustable 5 volts. Fix siya sa 5 volts. At ang current limit niya nakaset sa 1 ampere. Ito na ngayon yung ating pinaka module. Nakakonect yung ating ammeter sa ating battery para ma-monitor natin yung charging current. Oy, ano na naman ang mangyayari dyan? Ha? Aba? O, tingnan natin kung mababago natin yung charging current. Ayan o, i-adjust natin. Dito, 0. Pag in-adjust ko yung potentiometer, ayun o, 14, 23, ayun, 25. Dito naman, 17, may loss. Pero nababago yung kanyang charging current. Nagcha-charge siya. Kasi yung indicator niya pula. Pag pinatay natin yan, mag-i-standby yan. Ang indicator niyan, ayun o, green. 0. Magiging pula, Cha-charge, Naging 27, 23, 22. So, siya ay nagcha-charge. Diba? We have now this adjustable current charging TP4056 module. As you can see here, this is the TP4056 module with the protection IC, switching MOSFET, and then charging IC, and micro USB. We connected a 5-volt supply to the input, connected in the IN plus and IN minus. And then the battery is connected to B plus and B minus with a tester connected to the negative part of the battery. And then the output, there's no connection for the output yet. In order to achieve this current charging variable or adjustable, we need to remove the existing 1.2K resistor, and for the replacement, we replace that with carbon film type resistor of 1.2K with 10K potentiometer in series, because originally here in this figure, this is the current sense resistor of the 4056 1.2K connected to pin number 2 and then to the ground. 1.2K resistor now is being removed and replaced by the 1.2K carbon pin resistor in series with 10K potentiometer. The wiper is connected to the other side of the removed resistor. Then the other side connected in the left side of the pin. So, if this is the potentiometer, what we have is the potentiometer with adjustable pin 1, 2, 3. So pin number 1 is equivalent to the potentiometer with rotating with shaft. Here, pin number 2 is the wiper that is in the middle of the potentiometer, and pin number 3 connected to the 1.2K resistor. So when we adjust the potentiometer clockwise, it is the same as we are adjusting the potentiometer upward. So initially this is from 1 left side, and here it is from here pin 1, and adjusting it, moving the wiper upward. So initially it has no current, 0 ampere if the wiper is connected to the pin 1. Once we adjust the potentiometer clockwise, it's the same as moving the wiper upward. So it will continue adjusting upward, and it will get a certain value charging current. So it is changing, or we are now capable of adjusting the charging current. Once we rotate the potentiometer, as the same here, it moves upward until it reaches 1.2K, which is 1 ampere in the data sheet of the TC4056 module. Once the wiper has reached the point 3 or the terminal 3 of the potentiometer, and it can be seen by using a tester. We connected the tester to the negative side of the battery, from positive to negative, negative to the negative of the battery, and we will now see the effect of changing the charging current because of we use the tester and with potentiometer, adjusting the potentiometer. Just like here in the diagram, it will move upward. So it will get a less resistance, which means a higher value of the current, charging current. So this is the modification of the charging of the TP4056. Meron tayo dito module. Okay? Ito ay MT3608. Siya ay boost converter. Yung kanyang small voltage, i-boost niya. Step up into a large voltage. Depende sa adjustment ng potentiometer. From a small voltage, ma-achieve niya yung large voltage, big voltage, upon adjusting the potentiometer. At itong ating ikakabit sa ating gagawing power bank. Ito na ang ating project. Nakakonekta na yung ating boost converter sa TP4056. Yung battery ng ating module 4.095 volts battery voltage. At ito, yun yung output voltage. Pag in-adjust natin yan, pwedeng taasan. Tumataas 7.7 baba natin, gawin natin 5 volts. 5.5 volts. So kahit taasan natin yung voltahe sa output, 4.095 pa rin yung voltahe ng battery. This is now our power bank made up of TP4056 module and then the MT3608 boost converter. Battery is connected to B plus and B minus, and then connected also is the tester, green color tester, green tester, in order to monitor the voltage of the battery. And into the output connected to the input of booster. The output minus connected to the voltage input of the booster. And then the voltage output is, there is a tester, a yellow tester, to monitor the output voltage. We are going to adjust the potentiometer to achieve the desired voltage output, turning the potentiometer counterclockwise so as it increases the voltage output. Counterclockwise. turning the knob o potentiometer counterclockwise will achieve a voltage of 5.05 volts. While the voltage at the battery still 4.095 volts. 4.095 volts. So you can increase the voltage output by adjusting the knob o potentiometer. Since we are making a power bank, that's why our desired voltage output is only 5.05 volts. But you can increase, since this is a voltage boost converter, up to 20 something volts, 25 volts or more. But here we are making a power bank, that's why we adjusted the desired voltage for just 5.05 volts. And now we have this power bank.
Ayan, yan na ang. At saka ang may kanya sa. Sarap. Hindi mo pagkanak.